Well, we are back from 3D Experience World 2025. I had an amazing time seeing all of you that came this year. My voice is still feeling it. I am still feeling it. I am exhausted, but I had a great time. If you missed that event, Sean O'Neill and I did our best to try to cover the whole thing. So you can go on over to the SolidWorks YouTube channel and hit on live, and you'll see that we've got 3 days worth of streaming that you can check out and catch up on what you missed. Now, right before that event, I put out a video, this video, sort of modeling this wacky snowboard with this projection method. And in the middle of the video, I jumped back in and I said, oh, hold on, there's some additional information that I should put in here, but I'm not going to put in here. And this is that. So let's just dig right in. I'm Jesse, and these are some solid ideas. Now, there are a couple of methods that you can use for doing something like we did in that video. And again, if you haven't seen that video, I'll put a link to it. You can go check it out. Or if you just like watching things in reverse order, like a 2000s adventure movie, I'm with that too. You can stay right here. Really, the two options that we have, or two basic options, would be to project something, which is the method that we used in that video, or you could wrap it. Now, I wanted to talk about the difference between the two of those because it might affect how you do things in the future, and it's always good to know what assumptions you're making when you're using some particular method of modeling, right? So let's talk about the first method, which is the projection. Now, we said that the projection method works pretty well in this case because the base geometry is fairly flat, and that's exactly right. If we think about projection as shining a light onto another surface, that's essentially what it is. So if we were shining a circular light onto a plane, we can kind of visualize what is happening here. If the plane is perfectly flat, then you're going to get a perfectly circular shape as it lands down onto that plane. But if the topology starts to change a little bit, we see that that light will have to warp a little bit as it maps to that geometry. So the more exaggerated that shape is, the more distortion you're going to get in the vertical axis. Now, this could get to a point where it's so extreme that your projection might actually break down altogether, and you might have discontinuity or some strange connections between them. So that's important to know, that the projection can really only handle what it can see if you can see it from the direction of projection. And that's a great point as well. Projecting in a normal direction will give you the least amount of distortion. If you were projecting from another angle, let's say the light was off to the side, you're going to get some stretching automatically because you're facing a different angle. So it's important to be aware of these factors when you're using that method. Try to keep things projected as normal to the surface as possible and onto as flat a geometry as possible. So if that's the case, it's helpful to know other methods for doing things. And that other method would be to wrap things. Now, why didn't we just do wrap in the first place if it's a more accurate representation? Well, wrapping comes with its own struggles as well. Wrapping is a little bit more complicated, and in some senses we lack a bit of control too, because the system is just trying to get things as close as possible. Now with a wrap, we see that the wrap is still using a sketch that's in 2D, right? We're sketching in 2 dimensions generally when we're working in CAD. So to take that 2D sketch, we still need to do something to bend and warp it into the shape that we want. Now we'll notice that the shape that we want to bend it onto is not flat. That's the whole point of working with one of these methods. So when we're wrapping this onto a surface, it's going to take up some of its length. If we take that 2D sketch and wrap it down onto a 3D shape, it's going to come up short. We're using up some of its length to follow the ups and downs of that shape underneath. Now, that being said, you might be able to get better or closer or more representative geometry using the wrap method, but you might have to fiddle with it a little bit more. So it's going to be one of those trade-offs as to what you need, what makes the most sense for your given application. So let's look at this again. And in this case, rather than doing the projection, maybe we'll take a look at the wrap option. So I've used the same sketches that we had in that previous video. Again, if you haven't seen that, you can go check it out. But we have up to the point that we were going to use that projection and just trim that surface out, leaving us with the 3D geometry. Now, if we were to do something else instead, this is the method that we would use. So let's take a look at this sketch here. And in fact, let's change our sketch color so we can see this a little bit better. I'll right click on the sketch and change our sketch color, and we'll just make this red so we can see what it is we're trying to do here. Again, as a reminder, if we look from the top view here, we have this sketch that's exactly to length. I'll use my arrow keys here with my Alt key just to flip this over so we can look at this in the same orientation. We have this matching in length. So we've got from this point all the way down to the middle. And again, that was because we could measure that out using this projection method. We were going to project this straight down. Now, if we were to use the wrap method, that works a little bit differently. So on the features tab, if we go up to the wrap tool, you'll see that the wrap has 3 different methods. So I'm going to select our sketch that we want to wrap onto this geometry, and you'll see that we have the ability to emboss, deboss, or scribe. So these first 2 are actually adding some geometry. So if you want to add a boss that's wrapped on, or a deboss, a cut into the material that you already have, we only have a surface here. So what I'm going to do is leave this on the scribe option, and that will just cut the shape of the plane out. All right, so what we have underneath that is the wrap method. Now, if you have a cylindrical surface, for example, you could use this analytical method and be able to wrap that around a cylinder. It can do that mathematically quite well. If you don't have that sort of analytical type surface, in this case we have a spline, you'll have to use this secondary option, which is the spline surface, and that will try to map it to something else. Now you can see this is where things get a little bit more tricky, because it's now trying to wrap this along the length of the surface and just doing its best to approximate that. So we have here the sketch that we're trying to project, or in this case now wrap. And in the second selection, we can choose what we're trying to push that onto. So you can see that once we select this, you'll see the sketch preview is now working its way up, and it actually falls a little bit short of that top edge because it's now taking up some of that length to move up and down in this case, our y-axis. Now all we have here for controls is just a slider. So we have a low to high accuracy. So depending on what you're after, you can use that slider. But again, that's really all of the control that we have. So if you can get this massaged into a place where you're getting more accurate results, that's perfect. If you can't, you might have to use some other method or use a project to try to get things more locked into place lengthwise, in this case, in the z-axis. And give up some of that accuracy in the y-axis. So let's go ahead and we'll say OK to this, and we'll see what actually happens here. So once we allow this to wrap itself in, we now have this geometry that is the resulting geometry. And again, if we look at this from the top angle, we'll go back here, we'll see that this no longer matches the projected shape, or what would have been the projected shape, which is our colored red sketch here, and it falls a little bit short. Actually, on both ends falls a little bit short because it's using up some of that length to go up and down as it rides the ride of the shape of that surface. So it is resulting in a more accurate shape along the distance of it, or along the distance of the spline as it follows the spline. But it's going to be a little bit more difficult for you to get this laid in place to try to get the actual overall dimensions to line up, because you're using up some of that distance as it goes along, whichever the shape of it is. From there, you can use delete face and remove the things that you don't need and be on your way, just in the same way that you would with the projection method. So it's important to know what those options are. One may be more accurate in one direction versus another. So it's good to know what assumptions you're making when you're using these methods to create geometry. So hopefully that helps clarify things a little bit and gives you a better idea of what you're up against the next time you need to do something like this in SOLIDWORKS. We'll see you in the next one.